Hey guys, welcome back. I thought this week we would continue with multiplayer replication, so if you haven't watched it yet, definitely check out the channel and watch the first video I did last week, which will introduce you to some of the more fundamental concepts like replicating variables and replicated events in the game. To set up here for today's video, I thought we'd do some more like actor replications, some more sort of in the level things. So I've got here 2 player starts, and we're using the first-person game mode with the first-person character assets. So, over here on the left here, we'll find our first-person BP. In the blueprints folder, we'll have our first-person character, which we can open up and take a quick look at. So, I've had a little bit of a play, but just to recap here, what happens when we hit fire? Actually, we'll get rid of this touch here, just so we're not confused. So, when we hit fire, which is left mouse, it's going to play our animation, play the shooting sound, get our player's viewpoint, spawn the projectile blueprint, which is here, which is just a yellow ball with physics enabled and collision set to physics actor, and that is it. Then we get some variables here. We add our impulse to actually shoot the ball across the map, and then we do some line tracing. So we're not going to need a lot of this. We'll delete this calculate adjusted direction. We'll delete all this line trace stuff. There we go. We're not going to need the start trace variable, so we'll just connect that like that. Save ourselves some space. And we'll move some of this stuff around here. All of this is good. We'll need all of this going forward. Okay, so the first thing we've got to do to get prepared is to sort out our player pawn here. Because remember, if we hit play and have a look at what's going on, for one thing, the projectiles aren't being replicated to the client, and neither the client nor the server is replicating the up and down values, the pitch of the gun. So as I move the gun up and down, we're not seeing it for the other player, and the same is true for the server player to the client. So we're going to have to correct some things here in the pawn so that it replicates properly, because for some reason the character movement doesn't replicate pitch. So in order to do this, we'll come up here to our input axis lookup, because this is our pitch here. I'm just going to drag this out to the side, and we're going to need to make ourselves a new event. So let's get ourselves a custom event. This will be called correct pitch. We'll call it correct pitch remote for the remote client, and we'll set it to run on server. Because the client, the character pawn here, has authority to run things on server. We don't need to go through a switch has authority. We can just run and execute on server from a player pawn, even if it's the client's player pawn. And from this, we're going to need to set our variable here. So we'll make ourselves a new variable, call it rotation. Make sure that we set it to be a rotator. And then I'm going to drag it in here with Alt drag to get a set node, which we'll just hook up here like this. And we'll also need an input for our event here. We'll also call this one rotation and set it to be a rotator. There we go. So we can connect our event to our variable just like that. The next thing to do is to run this on every machine, so the server and all the clients. So we need to duplicate this event. It's going to come up with an error because it's tried to duplicate the same name, but we'll call this one correct pitch server to show that it's going to be, well, actually we'll call it multicast, just so it's not confusing. Multicast. There we go, and we're going to set this one to multicast, so it's going to run on everyone's instance of the game. And then from here, well, we need to set our pawn up actually, because at the moment the mesh is bound to the it's parented to the camera. So when the camera rotates, when it rotates us left and right, it's going to rotate the mesh. Same with up and down, but we're not getting the up and down. We're not getting the pitch. So we need to change the way that this pawn works here. So I'm going to drag the mesh 1p onto the camera to detach it. And we'll come up here to add component, and we'll add a scene component like that. And we'll call it weapon pivot. And we'll click and drag the mesh 1p. Oh, it's a child, so we have to detach that first. Then we can drag it on. There we go. So this is the tree we're looking for. Weapon pivot is the parent of the mesh, which is the parent of the gun, which is the parent of our muzzle point over here, where we fire our ball from. Then back in the event graph, we'll drag in, we'll get our first person camera, and we'll get our world rotation, because we need to set our rotation variable here to be a, to derive its values from our camera. So let's get our lookup here, our input axis lookup will come out of this input here, and we'll get our remote event and plug in our camera rotation into that event node. Okay, so the last thing to do is to actually set the rotation of our weapon pivot. So if we drag in our weapon pivot and come out of this blue output into a set relative rotation, we can connect this to our multicast, connect our rotation, and we're done. Although, actually, no, we don't need all of the rotation because the camera is still going to be handling our Z rotation. What we need is just the pitch. So we'll just connect up Y, just like that. And then we're done. So this is what we need to do to correct our pitch when we're replicating variables across the network. So just keep this. This will give us our proper rotations, but the story is not quite done, because if we compile here and then play, okay, nothing's happening. All right, we're never calling our multicast. Okay, so out of this correct pitch remote here, we'll come out of here into our multicast event. Correct pitch multicast, we'll look up our rotation. Okay, now we'll compile that, then we'll hit play. And there you go. So while it is rotating with us, it's not good. But you can see the rotation is being replicated from server to client. There we go. So we can see that on both screens. It's not replicating quite right. But that's okay. We can fix this just by adjusting some of our transformations here. So our weapon pivot is currently sitting at ground level. We want it to sit up sort of about where the camera will be sitting. In fact, we'll just reset this point, drag it up here. See, we get about the same spot as where the camera is going to be rotating from. And then our mesh 1P, this just comes back down to ground level. Just like that. Okay, so it's going to look the same as it did before, but when we hit play, we are a bit off to the side. Let's drag him back over. There we go. So now our rotation is much, much better, much more like it was before, and you can see we're inheriting the rotation in all directions now, not just in the left and right. Still a little bit weird that there's no body there, but we'll handle that probably in a future video. We'll do some more sort of animations and model stuff. Anyway, I'm starting to ramble, so let's just continue. So now we've set up our pawn here, so it's getting that rotation properly using our replicated events. Now it's time to replicate the actual shooting, because we're not seeing any projectiles fired when we hit shoot like that. So to begin thinking about how we're going to replicate our shooting, what we have here is our fire event. I'll get rid of this comment. There we go. So we have this fire event, which is all of these nodes, which is going to handle everything associated with shooting. But we don't need to use everything on the server. Like, not all of this has to be replicated. In fact, what we can do here is just grab some things that we just want to do on the server for everybody, such as play your animation and then play the sound of you shooting. So we'll disconnect our fire input here. Disconnect here at this play sound out location. I'll just zoom in so you guys can see. So this is all we want to have happen for everybody, for every client. So we can come out of this montage play, we'll grab ourselves a custom event, and we'll call this one fire underscore multicast. Because this is all that's needed to travel over the network. We can do all of our spawning and things just on the server, but every client and the server itself needs to play this animation for the player that fired and play the sound for the player that fired. So this is our multicast event, and that's just going to chill just over here a little bit while we handle the rest of it. So this is what we want to have executed on the server, and we can in fact reduce some traffic here just by, we'll come out of this get rotation from X into this multiplier, and we can get rid of this variable here to save us another execution step. It's all about optimization when it comes to replication. We don't want to send too much data over the network, or we get overflows and people get crashed and disconnected and things, and it's not good. So keep it as minimal as you can. One other thing I want to mention here is that if we get our replicated event here, we see this checkbox called reliable. A reliable event, if that's checked, is going to absolutely guarantee that it's going to travel to the server and back, and you'll get your result every single time. This creates a lot of overhead, so you should really only reserve this for your most important events, such as, well, this multicast event, not so much. We can skip an animation or a sound, but actually spawning our projectile, this event should be set to reliable. So we'll leave that multicast as unreliable. And to be clear, unreliable doesn't mean that it might not happen. It just means that if there's too much traffic, it might be one of the things that'll be dropped. But if you set to reliable, then it's at the top of the list, top of the priority. and it'll absolutely get there. So out of our get player viewpoint here, what we want is another custom event. This will be our fire server. Let's put that there so we have some space here. This will be a run on server event. And at the top of the chain, we have our input, our actual input in the game, which we want to then use to control how and what we're doing, how we're shooting. Let's come out of this fire event and grab our fire server. This is the one that just executes on the server. So we hit this, and like I mentioned before, a pawn can have authority to do things on the server, so we can fire a server event without first going through our switch. So we fire our fire server event, which is going to handle our spawning of the object and then the impulse to fire it. But we also want it to play the montage and the sound. So we'll come out of our fire event here, and we'll get our fire multicast and add this to the chain. And there we go. I think we're about ready to start testing. So we'll compile that, hit save, and then we'll hit play. Spawned on the same spawn point. Okay, so our server is... Okay, so our client is firing balls on the server, but the client itself can't see it. And the server is firing balls for itself, but the client can't see it. So the balls aren't being replicated over the server. But we kind of knew this, because if we go up into the projectile BP, it's just a ball. All the settings are default, except it's got physics turned on, and it's been set to a physics actor. If we go up here to projectile BP self, the actual blueprint details, we'll find this checkbox here called replicates. If we click that, and we'll also check replicate movement as well, so its location, rotation, that kind of thing are replicated over the network, as well as the actor itself, as denoted by this checkbox. So we'll compile that, then we'll hit play. And let's get my guns here in position. So now the client can see the server firing balls, and if I alt-tab over to our client player, the client is firing balls that the server can see, and we're inheriting that shot in every direction. Alright, so we're replicating the gameplay really well at this point. There's a couple other things that I'd like to cover, so we'll just save everything. I'll do a little quick recap here. So what we're doing is getting the correct rotation of our weapon here. We set up the different hierarchy in our pawn components. And then we split up our fire events over here. So what we have is that when we hit our input, we fire off this run on server event, which will run this multicast event, which will play our montage and play our sound. Then after that, we get the player's viewpoint, we spawn our actor, and then we add that impulse to where it spawned. Okay, with that all sorted out, let's go back to our content browser here. Let's right-click, make a new blueprint, make it an actor. I'm going to call it target_BP. And we'll just open it up. In here, I'm going to add a cylinder. This normal cylinder like this. We'll set its Z value to 0.05, something quite flat there, a little disk that we can shoot at. And then we'll compile and save. Over here in the event graph, we can... No, there's a little of these to start with. Let's grab our cylinder actually, and we'll scroll down here to collision. I'll just move this over. As you can see here, there's a checkbox for simulation generates hit events. So every time a physics object is going to bounce off it, it's going to register a hit, and then we can do stuff based on that. So we'll check that box so that it generates hits, and then down at the bottom here, we have at the top of the events an on-component hit. So we'll click that. As long as we had our cylinder selected when we did that, which we should have to see this list, we see on-component hit cylinder. All right, pretty straightforward so far. So when the cylinder gets hit, it's going to fire off this chain. And what we want to do, let's say when the cylinder gets hit, first of all, we'll just do some testing. We'll make it print a string. So let's compile that. We'll hit play. Well, let's put it in the map first. There we go. Put it here somewhere central. Then we'll hit play. And we see here our disk, our little target disk. I'll move this to a place where both can see it. Okay, so if I shoot this, as you can see in the outputs there, when the server hits it, the client and the server both fire that hit event. For the client, we see the same thing because the ball here is set to replicate. So it's replicating over the server, so a version of it exists for both server and client. This is what we want, although we can refine this a bit. So there are things that we can change. So if we get rid of this print string, and we'll come into a switch has authority, Should have deleted the print string. and then we go into our print string. There it is. So if just the authority has can make the print, then we hit play. So from the server, just the server is going to register that hit. Of course, because the ball is replicating, it's going to also happen when the client shoots it. So this is good. This means that everything's replicating just fine, and we don't even have to replicate this particular actor. But bear with me, there's more to do here. So let's make a custom event. Let's call it change color _ server. Making things change color, it's a good way to test replication, I think. Good way to make sure that all your components are replicating. We'll set this to be a multicast. Compile that. And then, well, because the ball is replicating, our projectile replicates, therefore it's executing this hit on the server. That's why it says server print string server hello. That means that because we have server authority, we can run a multicast. So we don't have to go through this switch in order to get that server authority. We can just straight up run a multicast event. Change color server, just like that. Okay, now let's grab our begin play node, because if we're going to be manipulating the colors of things, we need to grab our cylinder and then create a dynamic material instance, which will connect. The material is going to be just its regular material. We don't need to change anything in this node here, but over here on our server event, if we duplicate the cylinder node here, and then set vector parameter value on materials, the parameter name is going to be color, and we'll just make it turn red. How do I know it's color? Well, if we grab our cylinder here, we see it's got the basic shape material. If I hit that little magnifying glass to zoom in on it, open it up, it has a vector here called color. So we can access that vector within our blueprints by, well, first creating a dynamic material instance, so it'll change on every instance of the material, and then by setting that vector parameter on materials with that parameter name. Okay, that should be pretty familiar to you guys, and now we've got our events all set up. We are ready to test. Let's compile that, save it, hit play. Okay, so we've got the server. Let's see, here's our client. There we go. Yeah. Okay, so we'll try again. I'm thinking the screen recording's making some sort of frame rate lag. We'll see here. So, okay, so it is replicating. I think my screen recorder is sort of making it stutter a little bit. Physics calculations are very heavy on the network. You probably won't get the results you might check. But if we did this with a line trace, you'd see that it worked. You'd work just fine every time. In fact, we might do that. So here in our in the first person character, let's disconnect this player view. Well, actually, we'll just come out of this file multicast. Let's get a line trace by channel. Trace channel visibility, debug type. We'll go for duration. Set our duration, 5 seconds. And our start point. Well, let's just real quickly set up some line tracing here. We'll get our first person camera, get the world location, then we'll get our forward vector. I'm just going to multiply the forward vector by a float, something like 1500, and then add these two together. There we go, and there we have our start and our end points. The start point is obviously the world location of our camera. The end point is a result of this calculation here, and we can plug this in. And, well, that should be all we have to do. Actually, we'll break our hit result, get our hit actor, and activate. Oh, component, hit component. And activate that component. All right, this should work. So we'll compile that. Back in our target, we'll change this onComponent hit to an onComponent activated. There it is. There we go, so we'll compile that. Alright, so here we are. Oh, yep, so we've got our line trace going, and let's get our disk there so that we can all see it. And boom, yeah, the line trace activates the disk without any trouble at all. So that pretty much wraps that up. So yeah, I think my screen recorder was affecting the frame rate, which was affecting physics calculations, so the ball wasn't quite hitting every time. but we can confirm that it works. We just gotta... Oh, right, I gotta also reset this. There we go. Where is it? There it is. Yeah, so the server can do it. It's just your physical calculations are tied to your frame rate, which can get bogged down if you're doing things like screen recording, apparently. So we'll save that. The last thing that I wanted to talk to you guys about, if we go over to our projectile here, and in the root component, over here at net update frequency, this is an important value because it controls how frequently your assets need to be refreshed, like replicated over the network, how often they need to communicate. And the higher this value is, the more overhead it creates, and the more problems you might encounter. So be very sparing with this. Keep things that you don't need to update too often down at very, very low, something like 1 or 2. This ball here, it doesn't need to update that fast, like with its events and that kind of thing, because there are no events. But this might also affect things like how often it updates its position and that kind of thing. So you might also want to keep it fairly high, somewhere up like 60. Other than that, though, I think we are about done. So thank you guys for watching this far. I hope you've enjoyed learning about multiplayer. I've got a few more ideas for things that we can do. But until then, we'll catch you guys in the next one.